Well, first, let's start off. We have two awesome panelists this morning to kick off the day. We have Brendan here. I'll let you introduce yourself. That's probably going to be easy.
That's fine. I'm Brendan Kelly. I'm the architect for this structure, and I am a engineering. Both Charles and I went to Stanford, and there's definitely a geek squad here about building and building systems, which is one of the reasons why we wanted to start off with energy pieces. My career is very bizarre. I started with big laboratories and hospitality buildings, and I've gotten smaller and smaller and smaller. And I've been a developer, and really as soon as I was actually in between careers when the wildfires hit, and this is one of our firm's wildfire rebuilds, and there is no standard prescribed response for wildfire victims in my limited experience in Napa or Sonoma. Every single condition that we've met and talked to has a very unique scene on what has happened and what their new path looks like. All of them face the energy code requirements, and that's actually what this initial panel is talking about. Even though many of them have different paths, they all have to go through a very prescribed piece, no matter what the design is, what the systems are. And my background is in engineering, then a graduate degree in architecture, development, big structures, small structures, and I'm very, very happy to see all of you today, because I think this is just a remarkable point at which we can have kind of a joint conversation. So thank you for being here. And with that, I want to introduce you. She's going to introduce herself because she's not. It's much easier for me to brag about Nancy because you're never going to get it out of her. She was just chosen as Bill Dodd's senatorial district number 3 Woman of the Year. So let's just put her hands. Nancy is a renowned architect in her own right. She does a lot of production housing across the state. Very different from these custom residences, and it's actually one of the reasons why I wanted her on this panel, is that she actually deals with not just one house at a time, but hundreds of houses at a time, with many things that are not really controllable about alignment, siting, decisions down the road. So I wanted to bring her in for those other kind of conversations. Nancy is also a leader with Napa Solano Habitat for Humanity, and does a lot of workforce and affordable housing pieces. This is not just the energy codes that we face are making houses more expensive, and Habitat is one group that is dealing with the issues of making houses more energy compliant, even as it adds cost. So with that, Nancy, please introduce yourself. You would never get around to bragging about yourself, so I didn't want to step on you, but I knew that would never come back.
Thank you, Brendan. Brendan and I are very good friends, so I'm honored that he invited me to participate here today. The story of this home, I just want to take a moment to say that it's a remarkable story of hope for me, and all of the dark things that happen, like fires and things we see every day of our lives, that the response to it and how people get rebuild and find hope. Unending hope in the story of this home, particularly with Howard and Jared. And so it's very,
I see the faces of hope.
So just in the big scheme of things, the picture of something that's so positive happening here on so many levels. And the energy efficiency part of it, I'm sure, or I think everyone here is familiar with California's Title 24, that our building energy standards were brought into force to create a sustainable energy future for California, and it's been remarkably successful since 1978. Because of building energy standards largely, we have not had to build any new power plants. California's per capita electrical use has stayed very static, unlike any other state, and it's largely attributed to our building energy standards. So while they do cause a financial burden, the upside of it, that we build homes that people They are more affordable to live in. They're not subject to the fluctuations in energy costs. They're much more comfortable homes. They have better resale value, and ultimately, people who live in them can feel good about a home that isn't contributing to the demise of our planet. So that is where my passion lies, and particularly for affordable housing, because so many folks, just the conditions and situation of their life, that they don't have a lot of money to spend on their housing, and I feel that everyone is entitled to those same comforts of a well-designed home and an energy-efficient home. So I spent time as a technical advisor to the Energy Commission trying to find ways to move forward in designing homes so that are compliant with the Energy Commission. So
that's going to be a good segue to my first question. What are some of these specific changes to that building code for 2019 that we're seeing, and what's the direction that we're going in?
You know more, so I'm going to go first.
Okay.
The biggest change for the 2019 code is right now, somebody can build a 10,000 square foot house, spend millions of dollars, and put gobs and gobs of solar panels on the roof and call it zero energy, a zero net energy house, because the electricity use for their solar panels will be more than that house can use. And it will technically be green, and all of the greenwashing that goes with the zero net energy term will be intact. On January 1st, 2020, that house can build, again, all of the solar panels that it could possibly want, but it will not be zero net energy unless its building envelope is measured separately and distinctly for performance. So houses will have to be, not just, they definitely now will require solar panels, but you can't offset your building inefficiencies with solar panels. And that's the major, major change. If any of you are in construction or about to start your permit sets, you definitely want to submit in 2019. There are many other reasons that we'll get into today, but it will make it less expensive, less restrictive, and there are all kinds of buildings under construction today in California that are being inspected under 2016 code and the 2000. But it's about to change, and inspectors typically understand, like, okay, I'm inspecting to this code because you were building here. Just because you start construction in 2019, you go to 2020, doesn't mean that all of a sudden all those things are applicable to you. So I want to make sure that you understand that as well. Those are the big things, especially for residential. There are a number of other items which I'm happy to go to, but that's the big thing. Did I steal your thunder?
No, not at all. I slightly disagree with you.
Okay. Believe her. She's smarter than I am.
For builders, the energy efficiency has always been the cornerstone of the building standards. Efficiency first. And it is true, we do now have to provide renewable resources on your house. But the building envelope efficiency has increased another 9% under the 2019 standards. That isn't that much. The jump from 2013 to 2016 was 28% increase in your building envelope building efficiency. So this is a much more modest increase. So for those builders who embraced high performance walls and high performance attics and were early adopters, this next jump is not that big of a jump. It's not that significant. Now, the renewables, the solar, most of the production builders, because the Energy Commission is allowed the lease option, they're not going to absorb the cost of the solar. It's not going to increase the building cost of the house. So if builders have been building high performance walls and attics, we can get into details about it. This is not that significant of a jump just because of the solar. If builders have not been embracing high-performance walls and attics, and they were using the trade-off of putting solar on your house or using quality insulation inspection as trade-offs to high-performance walls and attics, those trade-offs are gone. QII is now going to be a prescriptive requirement. So now you're going to have to implement high-performance walls and attics. So you are going to see a larger increase than if a builder has already adopted high-performance walls and attics. So, yes.
What features accounted for the 9% betterment in efficiency?
slight increase in the performance of the high performance wall. It went from 0.051 to 0.048.
I'm not sure what that means.
Oh, I'm sorry. The efficiency of the wall assembly.
Okay, can you do that in R numbers?
Sure. It's the opposite. Well, like for a 2x6 wall, the increase in mandatory insulation went from R19 to R20. But it isn't that, because it depends on the assembly. It depends on the R value. What's really important to the Energy Commission is the thermal break is insulation on the outside of the framing of the house. That
Really?
You get more credit for each R point if it's on the outside of the framing because you want that thermal break. And there's been a lot of advance. We're used to seeing the 1-inch insulfoam on production houses. They're now looking at it and starting to implement polyiso and extruded foams that have higher R value and higher compressive strength, so you can even install siding over them and it doesn't impact the siding. So really getting your insulation on the outside of the wall is more important and more valuable in your energy calculations than between the studs. So,
So I'm looking at Charles, who's the Chief Product Officer at BareBONE. The two forces of thermal efficiency, where they want insulation on the outside of the building, and the wildfire threats, especially in the wildfire urban interface, where you want to protect flammable things like insulation, polyurethane and polystyrene, are directly opposed. So those things are a big part of what BareBONE and I and everybody else on this project have been. And there are some happy middle grounds. It's not like it hasn't been solved. There are many options within the code, and we will get into the wildfire piece in our next panel discussion. I just want to see a raise a sort of a show of hands. Who knows what a Title 24 report is? Okay, so I'm just going to spend a minute or so talking about this. Title 24 is the section of the California Code that describes building laws. It's in a very cynical way. It's the crummiest building you're allowed to build by law. But the section that deals with the energy compliance is called Part 6. But most everybody in the industry refers to Title 24. Part 6 as the energy compliance reports. Every new building and every addition over 700 square feet needs usually a consultant to look at the alignment of the building, the amount of fenestration, the assemblies that Nancy's talking about, where the insulation is. BareBONE has a very, very good and established system. When you go to the off-the-shelf energy software that most designers are having to use, from everything from high-rises to a beautiful custom home like this, you can't go down the menu and see the BareBONE 5-foot grid structural 11-gauge steel model that it's come from Canada. That option doesn't exist on the menu. And it's one of the issues that we had on this project, is that with the right energy consultant, they can see all of the work that BareBONE has done with the thermal breaks that Nancy just talked about. And actually, this building, under the 2016 code, is almost 30% better. It's definitely a zero net energy building, but even under the 2019 code, with a couple of minor things like quality insulation inspection, QII, which is something you'll all memorize by the end of the day. This building would also accommodate the 2019 zero energy compliance issues, because the building envelope is such a high performance. Now, did we really work hard on making sure that we could explain it with our software to the county and to the different inspectors? It is, but BareBONE's done it. BareBONE's reports through the Lawrence Livermore lab that they've all pieced, and I think Charles should sort of talk about that. There's another panel about thermal envelope, but in terms of the energy code compliance, everybody has to go through the same door, which is a Title 24 report, and it costs anywhere from $500 to $2,000 to get your building to accommodate it. And as soon as that report is done, your HVAC design, your window suppliers, I'm looking over here at Blaine Beckman from Anderson Windows. I mean, any phone call that I make to Anderson Windows or other window suppliers, like, I want to see your Title 24 report, because Blaine could not give a window price or an estimate if he doesn't know what the glass or the window assemblies are.
So just to clarify, again with the raise of hand, who knows what net zero energy means? So
I doubt it.
I-
The only reason why I say that is because I have found that there's a big misunderstanding about the 2020, what's going to happen in January. Everyone keeps saying houses are going to be required to be net zero energy. That is not the case.
That's correct.
While it was directed, by Schwarzenegger made the proclamation this would happen, the Energy Commission is under a mandate that when they institute policies, it has to be cost effective within 30 years. They came to the conclusion technology is not there. They could not mandate that if you run a house and comply with 2019 energy standards, it will not be net zero energy. It'll be about 75%. They couldn't force that to happen because it would not pay back in 30 years. So everyone's still calling it net zero energy. It won't be, and even that is really net zero electricity. Because most homes are dual fuel, they're not making you offset your gas use. So really, we know technically zero net energy means that the energy you use balances out with the energy you generate with over a year, because you can balance it out seasonally. But when I keep hearing everyone kind of think that just come January, every house will be net zero energy. Not quite true.
And also I think it's not about just reaching net zero per se, the global impact and the reason in the first place why, setting 2020 as a goal to reach higher energy standards is for all the homes that are being built, right? There's all these homes that if they all improve and reach 75%,
Right.
80% or 85% net zero, it's better than having
Of course.
a few homes that are very, very energy efficient, because we've had super energy efficient homes for a while now.
Right. California's way ahead of the game. And I just wanted to finish your question about how did the thermal envelope change. Also, the efficiencies in windows change the requirements slightly, and doors. And windows is very, very interesting because it's where all of the energy is lost now in houses. Our walls are great. When you do an infrared on a house, it's all through the windows. Windows are getting better and better and better, and we're seeing people using triple pane windows. There are window manufacturers. I don't know the Anderson rep, but both Milgard and Clydem now have a fourth coating on their windows that makes it as energy efficient as a triple pane window, and that's just a new coating, and that comes from technology from computer screens. So there's all these building components that as technology increases, it's making it more and more affordable to have these really, really great
What's the
energy. Do you know what I'm speaking of? Like Milgard has the I-89 window that has the fourth coating that increases the efficiency. I'm assuming Anderson is looking at
We do,
coatings.
yeah. It's inside, on the inside pane of the glass. Yeah, it just bumps that U value up a little higher.
Right, so there's options out there.
What's the best R value you can get with a window?
We use U value as our
U
measure.
value. It's the other
It all
way.
depends. It depends on, there's a ton of different things that go into to evaluate that. It's the glass makeup, it's the coatings on the glass, it's the frame material.
Okay.
All of that has to do with where it rates out.
So I'm assuming all of you are interested in building. This building, if it was, excuse me, if it was changed, if it was turned 90 degrees, would not comply with Title 24 report. The alignment of your building, and it's getting more and more specific with the increases and changes. This building was designed to get a massive load of sunshine early in the morning. And we actually reduced some of the protection on the windows so that it could heat the concrete floor. And it's a little after 10. By 11, there will be no sunlight in the major spaces of this room. I mean, obviously there's a lot of daylight, but there's no direct sunlight. There's one room at the very south end that will have a built pergola over most of the window. So the idea is that, especially in this exposed part of Sonoma County, for the major heat loads from, let's just say May through October, you don't want any sunlight on big windows. Now, of course, this is facing west, and there's a lot of glass here facing west, but when this building is finished, and you can see some of the renderings around the project site today, all of these will actually have sliding brise soleil wooden screens, so that in the wintertime they can be slid open and enjoy some passive heat, but on a July afternoon, that whole western porch will protect these windows from direct sunlight. So when you're talking to your architect, BareBONE is already doing this automatically, but when you're talking to an architect and you ask them, so like, have you thought about the Title 24 implications of your design? And they look at you with those big doe-eyed architect eyes. I'm like, we'll get right on that next week. Grab your wallet and keep asking really solid questions, because the changes are coming. If they don't really start with Title 24, BareBONE's technology, even as they rotate some of their standard designs, and especially the custom ones, they put so much thought into the Title 24 accommodation, especially California, that they can go to any other state in the country and accommodate what I would call higher end need or other energy.
So two topics I want to expand on is, yes, solar passive design, and does that translate to affordable housing and production housing? Is that something that you see there?
Well,
and secondly, also, I'd like to talk about thermal bridging, expand a little bit on that, especially, I guess, in this case, it's a steel structure, it's even more important, but is that something that we're seeing being addressed?
Okay, first, I would just like to follow up on what Brenda said. This is a masterpiece of solar site design. Carrie and Brendan did a remarkable job. It's so beautifully thought out. And one thing all of the builders are learning is exactly what Charles alluded to, is that, or what Brendan alluded to, that Title 24 is really starting to drive design. If you don't have an architect that's building it into the structure, you're going to have a very, very difficult time meeting Title 24, just because of the requirements of the windows. Just as importantly, the direction your solar panels face. That is now figured into the modeling software, that they've increased the azimuth window of where it's allowed to face. In the 2016 code, it was a little restrictive where your solar zones are. They've opened that up, but you want to optimize your solar zone or the direction of your solar panels. So everything Brendan's talking about, site design, is critically important. Unfortunately, many, many houses don't have the opportunity, because of the way tentative maps are laid out. This is where your driveway cut is, this is the way your house faces, that you don't have the opportunities to maximize the site solar planning. This is truly a masterpiece. It's humbling to me to see what Brendan and his wife are capable of doing. It's perfection. But so for me, I work more in production housing, for lack of a better term, affordable housing, or workforce housing, trying to make these things happen where we don't have ideal conditions to work with. So that's where the challenge lies. Okay, so the only thing I was going to say, one very interesting component of the new energy code is there is an allowance for off-site community solar generation. And I think there's a real opportunity there. It exists in Colorado, where there's mitigation banks where the solar is generated off-site in some place where you can optimize the orientation, keep the panels clean, and then you can buy into that as a mitigation bank rather than having the solar installed on your individual
Would that be like
house.
on a neighborhood basis, or?
There's been some talk about that. That's very difficult with the Public Utilities Commission of creating these little, it would be on a larger scale. There's a couple of them in the works in the state.
I see.
And so that's an opportunity, and also battery storage is another offset.
Yeah, batteries are a big topic.
It's a big topic, and when batteries get better, and we can really, because there's a problem with grid harmonization and time-dependent variables, that when the solar is generated, when you actually use it, it's great that most people, when they're at work all day, their house is generating all this solar. There is no, in the grid, or what we call, the energy distribution, there's no storage capability. This energy you're generating during the day, it's gone. So what the Energy Commission wants to see is generate that and be able to store it and use it in the evening when you come home from work, or if you have these large off-site community solar banks, like a lot of our utilities are, that ultimately are directions we're going. Battery storage is the holy grail, and it will take a while. We're getting there, but that's when people think if they have solar, they're off the grid. Not at all. You still have to be, you need to be hooked up to a reliable power source. But when batteries get there, it's going to get really exciting.
Are the signs of the building code going in that direction as well?
Oh, absolutely. Sort of at the 11th hour, they added provisions for community solar because there's investment groups that are forming right now to create community solar banks.
And in the 2019 code, you will get credit for plugging your Chevy Volt or your Tesla in to your grid, and the first electricity that you'll use in the afternoon will actually come out of your car before your car gets recharged before dawn from the rest of the grid. I mean, Howard and I were walking through here a week ago. We looked outside and saw obviously, he's looking at this massive PG&E transmission line that has gone through a lot of changes in the last year while this house has been coming out of the ground. And when he and Merritt moved here, all the electricity was coming down those transmission lines and serving this neighborhood. Today, at peak periods, with all these solar panels, the electricity is actually going in the other way very often. And then an hour later, it will be coming back a different direction. So even though it looks the same, it's behaving differently, and our energy grid and our building systems are very, very interconnected. I want to touch briefly before we open this for questions on the thermal bridging. Steel is not loved by the California building code. It's a beautiful conductor of heat, and when it is exposed outside, you lose massive points under the software about how Title 24 is measured. Now, BareBONE, on their own, went to Lawrence Livermore and went through assurances that this exposed steel that you see outside actually are all thermally broken. All the windows are thermally broken, and in the standard BareBONE solution, there are structural insulated panels on top of the steel beams that you're seeing on top of it. Now, I'm the architect, and I put my hand up about 9 months ago, and I said, I don't want those structural insulated panels. We live in Sonoma, and this is not Montreal, where it's minus 30 degrees, and we don't need that level of insulation. But what happened on our Title 24 report is that when we went from R30 or R35 on R50 roofs, we went to R8. And we really paid a price. Now, we're still well over in a zero net energy, but the half of the building heat loss and heat gain, heat protection is through your roof. And BareBONE's standard system is really where all buildings will go. And I think Nance and I were talking about this at dinner the other night. It's not by accident that all buildings are starting to appear as square tops, because these structural insulated panels are going to smack on to wood panels and steel things, so that there's a much easier way to align the solar panels, and so you don't have to move things around, and you can sort of just look up to the sun, for lack of a very unscientific term. But we actually went through another version of design, and there's actually now insulation rolling right over the top of these steel beams to meet Title 24. We don't have the structural insulated panels like you would see on a typical BareBONE building, but the thermal breaks on steel can be managed. They can be managed very well. R50 roofs are very
well, no, and the diminishing returns, once you get over a certain R value, it's worthless. You're throwing your money away.
Yeah. And
just as a comparison, we're looking at steel, but in wood frame, what a high performance attic looks like in a wood frame building now is the intention is to get the insulation at the bottom of the roof deck. For the last several decades, we're putting the insulation at the ceiling. A high performance attic puts it at the roof deck. And the point of that is keep the attic closer to the temperature of the house, mitigate that offset so your mechanical equipment and your ducts are not struggling so much. So that when you hear the term high performance attic, that's basically what the most cost-effective way that our production builders are doing. They're just literally wiring or strapping batt insulation to the bottom of the deck. You would think without air sealing and it's still a vented attic, it's still phenomenally effective versus putting just the insulation at the ceiling. So that's in a very low technology way how it's happening in wood frame. Some wood frame builders, they spray foam against the bottom side of the roof sheeting. Way better because it's an air sealer and a higher insulation value. So that's a great option and obviously BONE uses a lot of spray foam insulation. It's great because it's an inherent air barrier. So if you use batt insulation now, it has the part of quality insulation. Batts have to be fully encapsulated on all 6 sides. They have to touch a solid surface, chipboard, whatever. So with foam, you only have to partially fill the cavities, which you can see, to achieve your R value. With batts, it has to touch. You can't have an air gap. So that's why quality insulation gets tricky with batt insulation. So that's a little bit on high performance attics and thermal bridging.
It's a good segue for, I guess, one of the other panels after. We'll be talking about attics, not just for insulation, but for fires. With that, I think we can open it up for other questions. And then we'll break up.
What is the fire resistance of the foam you use?
0.
Zero.
The foam is terrific as an air barrier, keeps dust out of the house, keeps sound out of the house. Polystyrene and the higher sort of newer model is polyurethane. Polyurethane chars when it gets to high temperatures. Polystyrene, which this is really just a styrofoam cup. It's a block of, it's what you'd see on a floating dock. And on the inside, you need a layer of sheetrock as a thermal barrier to protect it from heat and temperature and combustion. And on the outside, all the yellow foam that you're seeing today is going to be protected by a ½ inch of plywood and another 3/4 inch of wood siding. So even though it's flammable, the wildfire urban interface and CAL FIRE have allowed that 1.25 inch of material to be. Now there's I know I'm getting kind of.
Is it fire-rated plywood?
Absolutely, no, it's not fire-rated plywood. It's just normal plywood. And the point is that it's an ignition barrier from the exterior and a thermal barrier from the interior. The point is not to make buildings fireproof. The point is to sort of protect inhabitants so that they can stay and organize themselves and then escape. But the point isn't to stay in this house in the middle of a wildfire event or if your house is on fire. The point is to make sure that it's not all just sort of like exploding all at once.
Just to be clear, there's no such thing as a fireproof or fire. Why he's saying that is it doesn't exist.
It doesn't. And the building code doesn't prescribe it.
That.
And you can talk about. We talked a long time about having non-combustible surfaces. The wildfire that swept through here melted steel cars. Steel melts at 2,400 degrees. And there is nothing in the world, concrete spalt. I mean, it's the trees and the inflammable space. I was in Paradise 48 hours after that fire with the Office of Emergency Services. And I saw beautiful little wood buildings with pine needles in the gutter and open vents, completely intact. And right next to it, stucco houses with tile roofs right down to the foundation. There's no such thing as a fireproof building. The idea behind this piece, and I'm sorry for the long answer to your very short question, is that the foam for performance gets you 99% there. And then you have to do what I think are very clear sense, long proven methods of providing ignition barriers on the exterior and thermal barriers on the interior. The whole thing is going to probably be encapsulated. Is Mike here? Well, it'll probably happen in a few weeks, but if the contractor were here, he'd say like, hey, not a few weeks.
And Brendan, can I have one thing about how fires work? Because when we talk about exterior fire-resistant materials, our firm, we rebuilt a house up in this area that the photos of the house afterwards the stucco was still standing after the fire. The walls, because the fire started inside the house as it did for this house. That it didn't ignite from the outside. The embers got up in the eaves and it started, the fire started on the outside. And the house that we rebuilt, it was the same thing. It was so strange. The stucco stood. There was so much lath in the stucco. The walls burned from the inside. It collapsed on the, and there was the stucco frame, which is fascinating.
Yeah,
Fires
And we're going to expand on
Yes,
that.
we will.
The next panel,
Yes,
the next
right.
panel is going to be specifically about building
In the wildfire zone.
in the wildland interface. So, yes.
What are the sort of automatic and maybe manual ways that you thought about the users using the house after it's built? I'm thinking about like automatic temperature gauges.
Oh, sure.
Like manually opening these windows to ventilate, like that kind of thing.
So this building was conceived of as a Sonoma County barn. It's open. It has porches. It has a view, and it's flat and cedar, and it's supposed to weather in place. The reason that we have two big windows, two big doors with sliding screens on both sides, is that on a day like this, the automatic sections will be Howard and Merritt opening the door. Will be Howard and Merritt opening the glass doors in the morning and letting the cross breezes sort of go through all day long, like they are now. And it should be a very sort of comfortable place. The automatic pieces, you can start to see the HVAC moving in. There's hot water. This is an all-electric house, and you get big rebates from Sonoma Clean Power. There's almost $18,000 for an $18,000 back to you. They literally just write you a check as soon as you show them you have an all-electric house. And that hot water heater is one example. When you move into a bathroom through a motion detector, it will start to recirculate the water. Now, if you're gone for a couple of days and it's not sensing the motion in the house of people moving around, the hot water will turn down and stop recirculating, and the energy use recirc pumps actually use a tremendous amount of electricity. But those are the kinds of automatic pieces.
Wow.
We looked at, there's all kinds of technology. Howard looked at these pieces. It's almost $1,000 per motor for an automatic window. And Howard liked the idea of his old school crane. Yeah. So when Howard wants them open, they'll be open. I have another client, another beautiful Anderson product where it's all hooked into temperatures and passive design. So at certain temperatures they open, and at certain other higher temperatures they close back, and the temperatures, it starts to cool, so that when they come back to their building, it's not, after a 98-degree day, it's a little sort of. Anyway, I think that
The most important part that this was addressed was solar passive design, right? So you don't have these fluctuations of temperature that you're trying to fight against. You're really just keeping the temperature naturally at a point where it's comfortable by having a really well-designed shell, good orientation, and good shading. So that's really the first step.
The other thing that comes to mind is very good AC equipment now incorporates something called concepts of pre-cooling the house, and the Energy Commission loves this. They love anything that shifts when you need to use the energy. That the coolest temperature of the day is 1 hour after sunrise. So that's the coolest time, when if you open your windows and you bring in outside air. A lot of people don't like to open their windows, so a lot of HVAC equipment now is designed to bring outside air, design it in and run it through your HVAC system, pre-cool the house. So if you can keep the house cool before those peak energy times, and a lot of very sophisticated HVAC equipment, that's how it does it. It does it by taking advantage of pre-cooling. And like I said, Energy Commission, all these kinds of things, you get a lot of Title 24 credit, because again, you're saving energy. You're not, it isn't just in your generation.
These buildings are so airtight that Howard and Merritt and Ray off for a day or two, or maybe on summer vacation, the door's closed. If automatically there would be an indoor air quality fan putting fresh air into the house. That for many years, the new buildings were being built and there wasn't enough fresh air coming into the house, especially while you were sleeping. And the amount of carbon monoxide and carbon dioxide was getting to these crazy levels, and it wasn't ignition or a leaky gas pipe. It was just, you were living in a plastic bubble. So in this house, and in many of the, and you get massive points in the Title 24 reports. Like, for example, when you go home and you turn on the exhaust fan in your bathroom, all of that heat or cool air goes directly outside. It's a massive hole that you're making in your bathroom or your shower. In this house, and in many of the houses that are under construction today, they will go through a heat recovery fan, and it will get exhausted, and more air, and that air will get filtered and come back through the house, not through the kitchen or through the toilet room or through something like that. All the technology are long fans, but the point is that there's no crazy exhaust of nice warm air going outside in the wintertime or cool air in the summertime. And that's probably, and that thing that Howard and Merritt will never realize, they'll never hear it, but they'll never also have to turn on an exhaust fan, and the shower will always be exhausting, and they'll always have fresh air, but the fresh air will be converted to current temperatures.
One thing we didn't talk about that I would just like to mention, another new big Title 24 Plus that's new to 2019 is compact hot water design. If you locate your tankless water heaters so that your runs are short, you get credit for that. And that's a big plus because in production housing, the #1 homeowner complaint across all the builders is wait time for hot water. As we've gone to the smaller PEX lines and how long it takes to take hot water. But what made me think about that is there's also the credit. I don't see anyone using this, but the heat recovery for drains on showers in places that are using hot water, you're now putting heat recovery coils on the drain lines that pull the heat out of it. So, I mean, there are some, it's pretty easy. I don't see anyone using that. But the compact hot water design, and now you also get significant credit for electric heat pump water heaters, which is new. That's new to 2019. We hadn't talked much about energy efficiency on the water end, but that's a big part of Title 24.
So does that mean that you have distributed smaller hot water heaters throughout the house?
Actually, that's the best way, and they've been doing it in Europe and in Japan that way for a very long time. That yes, the point of use.
It's less water.
Point of use.
Sure. It's massively less water.
Less heat.
Just ask my 15-year-old who will just keep the water on until it's the perfect.
Like this house, how many hot water heaters are?
There'll be one hot water heater for really. There's two. There's Howard Merritt and Ray has kind of the studio at the other end. Ray is Merritt's father-in-law. Is Ray here? He drove away in his Tesla at the age of 97 from a fire. And it's kind of the trail. So Ray has the other end of the building. He and his wife Sarah lived here for 30 years. And Howard and Merritt have a master bedroom here on this side. Between the three of them, they're going to share an 8-gallon water tank, but that recirculation pump that I talked about will keep the hot water for the kitchen, for that master bedroom, for the bathroom at this end, and the motion detector that will make sure that if Ray's here and Howard Merritt here, that recirculation pump will be concentrated on that end. So it's just a very small little electrical piece that is now, a $20 fixture that can make sure that those electric bills can stay down.
And that works because it's an electric heat, because it's an electric heat pump water heater. That's what we're talking about. That's what we're moving. But if you're using tankless on-demand water heaters, it makes more sense to locate them where, especially if they're gas, to locate them close to the source, to the use of the pump.
So we're gonna have to cut it off here.
I know, I'm sorry, I'm talking too much.
Sorry, me too.
No, Brendan, Kelly, Nancy Nelson, thank you so much. We'll be around. So
around.
please stick around if you have questions.
When is the next panel?
The next panel will be in about 20 to 30 minutes.
Great.
For wildfire.
Wildfire.
If you love Title 24, you'll love wildfire.